Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we will solve a problem which is related to the motion of fluid. Now in the previous lecture, if you have seen, there we have considered or we have discussed actually different types of motions of the fluid. So here we'll solve a problem related to the concept of this motion of fluid flow. So here I have taken the question like the velocity component in two-dimensional flow are u equal to yq by 3 plus 2x minus x square y and v equal to xy square minus 2y minus xq by 3. So what we need to calculate so that these components represent a possible case of an irrotational flow. Okay, we need to show this component that is a irrotational flow. Okay, so for that first what I'll write this equation what I've taken u equal to yq by 3 and this is plus 2x minus x square y. So this is one equation and another one equation is v equal to, so that also let me write here, xy square minus 2y minus x cube by 3. Okay, so here what I'll do, I'll just derivative of this u, let me write du with respect to dx. Okay, so let me find out the derivative of this velocity equation with respect to x. So what I'll get here, so this part there is no x term is there, so just it will be neglected. So derivative of 2x we can write 2 minus x square y. So derivative of x square will be there, this is a constant, so minus 2xy. So this is du by dx. Similarly, if I'll same equation, if I derivative with respect to dy, so we can get it here like 3y square because yq is there, so derivative of that divided by 3 and this term will be not there because only x term is there and here x square y, so that will be minus of x square will be there. That means if you cancel this 3 by 3, so it will be, what will you get here now, y square minus x square. Okay, this is one part, u terms. This is the velocity component in the u velocity. And similarly if you see the v, so again the same thing you do here, derivative of this is v with respect to x. Okay, with respect to x and with respect to y also both you need to do. So with respect to x, if you do, this is the x term is there, so only constant dx by dx will be 1, only y square will be there and this 2y, there is no x term is there, so neglect this, x cube by 3. So this one we can write 3x square by 3. So 3 will be cancelled and we can write this is y square minus x square. So this we will get. Now similarly again we can write derivative of v with respect to dy, same equation. So with respect to this one we can write xy square, derivative of xy square, so x will be constant term, let it out, uy square, so I can write 2xy and this is minus, only 2 will be there, so minus 2 because this term, third term is there, x square, x cube, no y term is there, so that will be neglected. So these two value we got here. Now what I'll do for the because this is given only two-dimensional flow. Okay, so let me write the continuity equation for the two-dimensional flow. What I know this one, del u, that means the derivative of del u by del x plus del v by del y equal to 0. So this is the equation for the continuity equation. So what I'll do, I'll just put this value what I got here, this derivative of derivative of u with respect to dx, the same value I'll just put it here. Then let's see what I'm going to get from here. Now if you see del u by del x, how much is there? 2 minus 2xy, 2 minus 2xy and plus del v by del y. Del v by del y how much? Del v by del y is again 2xy minus 2 and if you see minus 2xy cancel, this 2 will be cancelled. So what I'm going to get, I'm going to getting this value is 0. So that means the continuity equation, what is the equation is satisfied. So we can say it is the case of a fluid flow. So there is a possible case of fluid flow, first things. Second thing, we need to show that it is a irrotational flow. So there is a possible case of fluid flow. And second concept what we'll see here, we need to show that this is a possible case of irrotational flow. For the rotational flow, we know that omega z equation, you can write 1 by 2 bracket del v by del x minus del u by del y. Okay, now just to put the value of this del v by del x, how much is there? Del v by del x, that is bracket y square minus x square minus del u by del y, this one. This is also y square minus, so let me write y square minus x square bracket close. So this one we can give a square bracket here. So once we open the square bracket, 1 by 2, let it keep it only bracket here. So that is y square minus x square minus of y square plus x square bracket close. If you see, all the values are going to be cancelled here. That means the rotational component omega z is going to be 0 here. So that means we can say this is the case of irrotational flow, because irrotational flow, this is the condition, it should be satisfied. So what we got here, this component what is represented is a possible case of irrotational flow. So I hope you understand how to solve the problem when it is related to the motion of fluid. Only you just need to remember the formulas of this rotational component and the continuity equation, and we need to know the derivative of these things. So if you are having any kind of doubt regarding this or query regarding this, you can give a comment on the comment box. Thank you all.